Hi guys, this is our last section, everyone's favorite section, word problems. So let's look at some key words here that really trigger what inequality we're looking at. So the first word is at least. Anytime something says at least, that means greater than or equal to. No more than is typically less than or equal to. More than means greater than, and less than means less than. All right, so let's look at just some very, very basic ones. No words, just translating. So T is non-negative. Non-negative means that it is positive. 0 and greater are positive, so that would mean T is greater than or equal to 0. Everything greater than or equal to 0 is non-negative. Looking at 3, K is no more than 3. So if it's no more than 3, that would be this one right here, which means, not that one. This one right here, which means less than or equal to. So that means K is less than or equal to 3. V is no less than 7. So that means V is greater than 7. All right, let's do the next one. X is positive. So this goes into one that is very similar to what we did for 1, right? So that's going to be X is greater than or equal to 0. All of those are positive numbers. Last, R is at least 2. So that means R is greater than or equal to 2. All right. Let's go do some word problems here. Keith has $500 in his savings account at the beginning of the summer. He wanted to have at least, there's a key word there, $200 in the account by the end of the summer. He's withdrawing or taking out $25 for his cell phone bill every week. All right, so let's talk about what we have here. So right now we know he's currently got $500. He's withdrawing or taking away $25 a week. And he wants at least $200 in there. Okay, so let's work the problems first. Okay, so we know whatever it is, you got to have at least 200 in there. So we're going to put that there. We know he's currently got a bank account. That bank account is 500. But from that 500, he's taking away 25 per week. Now really quickly, we added a variable, so let's go ahead and put our variable. W equals the number of weeks. Okay, so now we have to think about this and really go back to like 6th grade when we were talking about, we'd make the alligators and it's got to eat the bigger number, right? So what number do we want to be bigger? Do we want the $200 to be bigger? Or do we want the amount that he's currently got in his bank account? Well, we want the amount in his bank account to be bigger than 200. Now we have to ask ourselves, could it be equal to that? At least would be equal to, so we are good. All right, so that is our first one. Let's go on to number 2. Uber charges $1.75 flat rate in addition to the 65 cents per mile. Katie has no more than $10 to spend. Hey, there's another word. We want to write an inequality that represents the mileage Katie can go. So again, let's look at some key words that we have here. So it's $1.75 flat rate, 65 cents per mile, and she's got $10 to spend. All right, so once again, she's got that $10. We know it's $1.75 flat plus 65 cents per mile. I'm going to represent miles with M. So again, I'm putting in a variable, so I got to write what that variable represents. M is the number of miles. Okay, so this part right here is representing what her fee is, or what she's going to have to pay that Uber. Do we want what she has to pay the Uber to be bigger or smaller than the 10? Well, if she's only got $10, what she better pay the Uber has to be smaller than 10. Now, could that be equal to 10? Yes, it can. Because she has $10. All right, there is our second one. Let's go with number 3. Chris wants to order movies from Disney Plus. Each movie costs $15.99. The subscription service costs $12.99. Chris has, at most, there's another one of those words, $100 to spend. Write an equality word to represent Chris's situation. Then we also have a question. All right, so looking at some keywords here. Okay, so each movie is $15.99. It's a flat rate of $12.99 just for the service, and he's got $100. All right, so let's dig in. So he's got the $100, so I'm going to put that over here. That's his budget, right? Okay, he's got $12.99 that he's already paid, plus $15.99 per movie that he'd like to rent. Again, I'm adding a variable, so I have to label my variable. M is the number of movies. All right, so now let's figure out which one needs to be bigger. This is representing how much he's spending. Should that amount be bigger or smaller than his $100 budget? That number should be smaller than his $100 budget. And because it's a budget of $100, he can spend up to that $100. So now we need to plug this in and see if we can spend 5 movies. So let's see. We've got our $100. We're going to see if that is less than $12.99 plus $15.99 times his 5 movies. So I'm going to plug that in my calculator right now. So $12.99 plus $15.99 times 5 gives me a grand total of $92.94. So because that amount is less than his $100, he can buy 5 movies. All right, let's go on to the next one. Starskate charges $50 flat rate to rent out the stadium for a birthday party. They also charge $5.50 per party guest. Your mom has a budget of less than $120 for your party. Write an inequality to represent the situation and example. Well, there's our less than. Let's talk about some key numbers here. So we have a $50 flat rate. We have $5.50 per guest. And we have $120 for your budget. All right, so your party is going to be $120, so there's that. Now let's talk about how we can get there. So we've got our $50 flat rate, plus we're doing $5.50 per guest. Again, I'm adding in a variable, so I have to label my variable. G is representative of the number of guests. Okay, so now let's think. Less than. So her budget needs to be smaller than the $5.50 plus the $50. All right, so lastly, they're like a number of guests. So let's pick a number that we think could fall within there. So let's try 10. Let's see if 10 is a possible number. So we have our 50 plus 550 times 10. So that's 50 plus 55, which is going to give us $105. That $105 is less than her $120 budget, so a possible number is 10 guests. Now you could have done something very low like 2, 3, 1. All of those are possible. All right, let's try our last one. Your baseball team has a goal to collect at least 160 blankets for a shelter. Team members brought 42 blankets on Monday and 65 blankets on Wednesday. Write and solve an inequality to figure out how many blankets the team must donate on Friday to make or exceed their goal. All right, so let's talk important words again. So we have a goal of 160 blankets. We have already brought 42 and 65. And we need to figure out how many we're going to bring on the last day. So let's get going. So we need at least 160. So I'm going to put 160 over here. Nope. All my pens are dying. Let's see. We got 160 right here. There we go. 160. Okay, so far we have 42 blankets plus 65 blankets plus I don't know. Okay, again, I've made a variable, so I have to write x is equal to the number of blankets that we're going to bring. All right, so we have to think, does this number, which is how many we've collected, should that be bigger or smaller than our 160? That number should be bigger, and that is just to meet our goal. So just to meet our goal, we need it to be equal to that. All right, so let's solve it. So we have 42 plus 65 right now. That's going to give us a grand total of 107. Okay, so I'm going to minus 107 from both sides. That will give me 53 is less than or equal to x. Okay, so that means they need to collect 53 or more blankets. All right, guys, that is today's lesson of word problems. The last page is actually the wrong page, so we're just going to skip that page for now. You can throw that one away. And that is it. So if you need to stop, pause the video, rewatch it, go ahead and do that. Your Big Ideas assignment is listed above. If you've got any questions, let me know.